Here are some examples of multiplying rational expressions. Problem 1. Find the product 8 over x squared times x to the fourth over 2x. First, let's write out these terms. 8 over x squared times x to the fourth over 2x. Now let's multiply both of the numerators to get the new numerator of 8x to the fourth. And at the denominator we have x squared times 2x, which will give us 2x cubed. Our final step is to simplify this expression. First, let's start with the numbers. We have an 8 in the numerator and a 2 in the denominator. And we know that 8 divided by 2 is 4, so we can cancel that and just get a 4. And then we have x to the fourth divided by x to the third. 4 minus 3 is 1, so we're left with x in the numerator and no denominator. So the final answer is x to the fourth. 4x. Problem 2. Find the product x squared minus 9 over 6 times 2y over x minus 3. First, let's write this out. X squared minus 9 over 6 times 2y over x minus 3. Now, just like before, we'll multiply the numerators first. So 2y times x squared minus 9. And let's not simplify this yet. And divided by 6 times x minus 3. First, notice that 2 and 6 can both be divided by 2, which would leave us with y times x squared minus 9 over 3 times x minus 3. But is this in simplest form? Notice that x squared minus 9 can be written as x plus 3 times x minus 3. And we end up with this. That's because any expression of the form a squared minus b squared is factored as a plus b times a minus b, as we've seen before. Now, notice that x minus 3 appears in both the numerator and the denominator, so we can cancel those. And we're left with y times x plus 3 divided by 3. This cannot be simplified any further, so that's our final answer. Problem 3. Find the product 5a over b squared times ab over 3a. First, let's write this out. 5a over b squared equals times ab over 3a. Now let's look at the right term of this expression, ab over 3a. You see that there's an a in both the numerator and the denominator, so we can simplify this before we even multiply them. So this is equal to 5a over b squared times b over 3, since the a's cancel. When things can be canceled right from the start, it's often a good idea to do so, because it can save time in future calculations. So now, let's multiply the numerators. We get 5a times b, which is 5ab, divided by 3 times b squared, so 3b squared. Now, the 5 and the 3 are relatively prime, so you can't take away any factors from both of those. However, there are b's in the top and the bottom. So if we cancel a b in the numerator and the denominator, we're left with 5a over 3b. Now it's clear this can't be simplified any further,